Okay, so it's a very simple little project. So it's one of those ones you can sort of do over maybe a weekend and a little bit. But I think I probably spent more time than that, but it's a sort of scale. It's not a big one. So the basic idea is that I want to build, I was thinking actually a solar oven, which is what you see down here on the right, bottom right-hand corner. So the idea of a solar oven is that you don't need any power, so they're quite common for camping or villages that don't have power, for example. And I realize that obviously if you follow the sun, you can get much better efficiency out of them. So you can see even the ones that are designed quite well, they'll have a limitation. So if the sun is totally above you, for example, they'll get very good performance. But if they're not, if the sun isn't right over top, then you're going to lose some efficiency. Then obviously the same thing with solar panels. So if you have a solar panels flat on your roof, then you get a certain amount of efficiency depending on the time of the day, etc. So this, essentially the idea is, well, can you build something cheap and easy to follow the sun and get the most out of the sun's rays during the day? So that's what I just try to figure out how to build quickly and easily. So very simple architecture. So I essentially have two servos, sort of a pan servo and a tilt servo. So that's the azimuth and the altitude. And then you've got your pi just using a couple pins. And then you have your ground obviously tied to a 6-volt power supply for the servos, so you're not, so you're driving it from a supplemental supply. Obviously, tie your grounds together. That is just so, as Tony explained in one of the previous meetings, is so that your pins and your ground, power ground going to the servos at the same potential. Otherwise, your servo is not going to react to the signal. So you have to tie that. So that voltage is literally just solder them together or wire them together somehow. So the basic idea is just shown here. As you can see here, I've got a very cheap little junction box that you buy from Screwfix or B&Q or somewhere like that. They're about £2 each. And I just cut a hole in the top for the base servo, and then the other servo sits on top. And you buy this little pan and tilt mechanism. I think I got this for about £4 or £5 or something like that. There's all sorts of ones that are available, but you can just pick one that's sort of meets your needs. Each of these servos is about £5 each. You can get from hobby shops. I did buy a more expensive one as well that you can get. So this one I think isn't that strong. We can buy stronger ones. I think it's 20 kilogram centimeters or something like that, or I forgot what the units are, but this one's strong enough actually. So if you try to push against it, you can't really push against it very easily. So it's just another picture here on the left-hand side, and you can see you've got the servo here again, the other servo on top here, and you can start to see inside the junction box. And that's shown again. So then here, it's just the underside of the lid. You can see here the pencil in the background gives you some idea of the scale. So it's not a very big device. And then this last, the last picture here just shows with the lid completely off. And you can see the Pi here and the PCB underneath here. And you can see I've made it's relatively waterproof, I guess. So you can see the USB coming in here for the powering the Pi, and the other power coming in here with some heat shrink on it. And then obviously the servo wires coming out. So I think most people know that servos are 3 wires. So you got your voltage, in my case 6 volts. You've got your ground, and then you've got your control, which obviously has to be at the same potential as the ground of your Pi. I think that's very straightforward. This green thing here is just a connector for the power, and you can see this. All this PCB board underneath does is just connect everything together. So it doesn't really do much more than that. So you have your 6 volts coming in, and it's feeding out 6 volts by the red wires here. And it is obviously has the ground, and has the ground coming in and feeding the 2 grounds here. And then it's connecting from the Pi here, Pi pins 5 and 6, going to the yellow wires here. That's all it's really doing. So quite simple. Like I said, it's just like a little small mini project. So the software, so I'm a big fan of what's called PIG-PIO, which is, it is available with the standard Pi distribution, but you do have to import it and use it specifically. It's just better than the standard GPIO handling in the Pi. You don't get any searching with the PWM. So when you apply the PWM to the servo, is rock solid. So it doesn't search. There's no searching as you would see from a software PWM. It's more of a hardware PWM. And then I use the Pi solar library. It just calculates the azimuth and the altitude. So the pan and the tilt essentially, and you feed in the longitude and the latitude, and then you get the time from NTP from the net. So cheap servos, they do require a little bit of fiddling around. So you got to sort out the angles and get the offsets and the ranges that you use. So you command between 0.5 and, so what is the values again? Yeah, there's just a range you use for the PWM to specify the angle. So you just have to fiddle around a bit to get that to work out. And then the Python code just ties everything together.
So Richard, just if I can go back one.
It all works quite well. So I've got it going every day on my all time during the day. Your north-south alignment, so you do have to align it south to north to make sure you're pointing in the right direction to begin with. But it's quite easy, and in fact, the pan tilt mechanism I have happens to have a hole in the middle that makes it very easily. So if you see the sun shining through the hole, and it's casting light onto your servo, you know you've gotten the right your north-south correct, and you can sort of see it, track it throughout the day. I also learned having in your bedroom is a bad idea. So if you imagine after the sun goes down, it goes around the other side of the earth, and the library, of course, keeps calculating that. So at some point in the middle of the night, it's going to come around to our side of the earth, and then the servo is going to go crazy and swing all the way to the other side. So you end up get woken up by this servo noise. Yeah, so that's something to keep in mind. It was a fun little project, so it wasn't too long. So sometimes you have these long projects that take, weeks or months, and this is not one of those sorts of things. It's just something you can put together relatively quickly. If you want to do something more complex or make it actually do something that's actually useful, you have to do more. But just for getting something up and running, it was just a few days. I do think it'd be quite an appealing piece in a home. So you could like make a little art piece out of it or something like that. So it does things, and if you look at 1 minute, look at between 2 different hours, for example, it'll change where it's pointing and stuff like that. So you can imagine if you had a piece of art that sort of rotates as the day goes along, in coordination with the sun, or maybe you're shining a laser onto the ceiling to show where the sun actually is. There's all sorts of things you could do to extend it. So you could consider your local conditions. So if you have this in the garden, for example, our house is essentially in the shade, or the garden's in the shade until about 11 a.m. or 12 a.m. or something like that. So you probably don't want it pointing at the sun. Maybe you want to point it at something that's getting a reflection from the sun, or maybe you just want to point it straight up until it reaches a certain time, and only then start tracking the sun. You could make a sundial. So I know people have come across lots of sundials in museums and things like that, and out in gardens, and they don't actually tell you the time very well. So maybe you just cheat and make it go make it rotate so the sundial is actually correct. You can make the first actually accurate sundial. Thought that would be a good idea. Maybe a parasol positioner. So in our garden, we sort of always struggling and really positioning the parasol so we're not sat in the sun. So yeah, it's just things like that. And I guess when you look at these sorts of things, it sort of mechanically gets difficult, but the concept is very similar. So that was the basic project. I think it's fairly simple. And recently I came across this thing called a smart flower, which essentially does that. And it uses the same sort of concept. It's a 24,000 quid, but they say it's 40% more efficient. And I imagine it's not just the tilting and the panning and the tilting. There's probably other things in there. They'll probably claim to be, but I guess the most of that will be the tilting and making sure that's actually facing the sun. So I provide the website there in case anyone's keen on buying one. There's a few interesting features. One thing that I thought was quite interesting is they, I think they needed a reason for it to fold and unfold itself. So they decided to, when it folds up, it cleans the solar panels. So maybe if some people have some solar panels, they would have an idea of how critical that is. It's probably a good idea, I think. So you can just imagine, they've got the pan and tilt there, then they also have a rotation mechanism. So all that obviously costs money. So I'm not surprised at 24K. It's quite a big device they've got there, and it's meant to produce a lot of power. So it's probably all right. So that's the project. I'll just stop sharing here for a minute. So that's the, so if people can see that, so probably not very easy to see because it's black. You see the hole here. So when the sun is up, that hole shines through, and if you have something perpendicular here, it'll shine if it's a perfect circle, it's aligned. So if you just delivered these and randomly put them in a location, I mean, as long as you have to maybe set the time. If you don't have internet access, you have to somehow set the time. But other than that, you should be able to just sort of focus it, really, I guess would be one way of saying it, just by having a sighting hole of some sort and have a way of setting it up. So you don't need a GPS, you don't have to worry about compasses and things like that. So I think it's relatively simple, relatively fun project, relatively cheap. So the whole thing is, it's like £2 for that, £10 for the servos and your pi, et cetera, et cetera. So it's, just something you might want to play with, just for a bit of fun. Obviously, there's other Python libraries, things like to follow the moon and follow different stars and stuff like that. So there's other things that like that are quite a bit of fun, I think. So that's my little project. It's a very quick and simple presentation. Hopefully that covered everything that would be people be interested in. Any questions on any of that?
So I've seen a few of these things where they use like 4 light sensors and a kind of cross assembly which casts a shadow. Did you look at that? Because that might get around your middle and right when there isn't any light.
Yeah, it's not a bad idea. So you could actively detect where the sun is.
Well, I love your idea of the library. The Pi Solar thing, that's a new one on me, so that sounds great. But you can see that you could do some if you get into it, you could do with some fine tuning.
Yeah, so I think it would be interesting to sort of put some sensors on there and detect how much power you're actually getting. I did try to do a very simple experiment. I put some blue tack on the ground and a blue tack on the arm, and sort of measured the temperature of it. But I couldn't really see any difference. Probably didn't have enough mass or whatever. I didn't spend enough time on it. Didn't take the experiment seriously enough. It's just one of those projects you just do quickly, and then you you sort of move on to other things and get busy with life or something like that. So I might come back and work on it again later. Who knows? It might be interesting. For example, I was thinking today that, you know, it might be nice to hook up something similar that tracks the moon, and every night it just takes another picture of the moon. So you could have like a sort of a slideshow of all the different moons. You know, if you get a high, one of the high quality cameras that they sell now for the Raspberry Pi, I think that could be quite an interesting little project for someone. Just things like that. Yeah, so there's a question there. Could you teach about the horizon? Yeah, so I think you could quite easily have something that, yeah, so you can limit it yourself. You can set up so that you know, it's not trying to find the sun through your house, for example, and things like that. So there's lots of things you could do. You could definitely have a night version that beeps every time and points to the ISS as it goes over. Absolutely. There's all sorts of things you could do. You know, you could, it's a good idea, actually. You could change the library that you're using for, depending on the time of day, or, you know, based on buttons or whatever settings. Yeah, so facing getting solar powers to face the sun as much as possible. I think that's a good idea. I was thinking if you have something on the roof, you may have maybe much easier to do a simple one that only worries about azimuth instead of you know, just the orientation. So you just change the angle rather than trying to rotate or like that. And I'm sure there must be devices out there that do that. And if you're only just trying to change the angle, I guess that'd be fairly simple to do. Any other questions there? All good. It's a very simple little project.
That was great. Could you modify it to fire Nerf gun bullets?
Of course. Do lots of things. But these little pan tilts, it's good fun. I really do enjoy a good servo project. You know, it's just,
yeah.
You know, the great thing is that there's a lot of different hobbies that use these. You know, so the recent ones I bought, they're waterproof, and they're quite a bit stronger than these ones. You know, they're obviously more expensive, but they're meant for remote controlled cars. So it's just like if you have another industry that provides all this stuff, then, you know, it comes out cheap and reliable, and lots of different makers. So
yeah, nice little fun project. Definitely.
Yeah, just a bit of play, really. I wouldn't. It's not. It is one of those things. I don't know if other people work on long projects. You know, some of I've been working on the same project for, you know, 6 or 7 years and not even close to done. So having a little project that lasts a weekend or two, you know, just something very satisfying and quick. You don't have to, you know, paperwork. You don't have safety engineers reviewing what the hell you're doing, or people bitching about your code. You know, you just get it done yourself and it works, and you decide when you're done.
Yeah, I know what you mean. I know what you mean. I mean, yeah, it's you know, short iterations and fast feedback is really, really good.
Yeah,
thoroughly recommended.
Yeah, I don't necessarily want to rely on some designer or coder, or, you know, just want to do this stuff myself and get it sorted out. Cool. So not any other questions. Just wondering if anyone else has anything they want to present or talk about.